Hello. So today I'm going to talk about the what is probably the most common type of capacitor you'll see, and I've got three of these little chaps here. They're ceramic disc capacitors. I'm going to talk a little bit about the markings on those and how you read them, and also I'm going to test the capacitance with this. Now this is a Maplin Precision Gold multimeter. It goes a little bit above and beyond the standard measurements that you can make on a normal multimeter, in as much as it measures inductance there in henries, and also capacitance in farads, and to some degree it also has a frequency meter built in. I can't remember what the frequency range is of that, but I remember it's a little bit strange. But that kind of doesn't matter for this. So what are the markings on these? Well, typically they have between 1 and 3 numbers, and then optionally a letter. And I'll deal with the letter first, and the letter corresponds to the tolerance. It's like the last band on a resistor. And in cases where it is stated, it's similar to the most popular resistors, which have plus or minus 5% tolerance. So I don't know if you can see this. I'm going to get a better camera so I can start doing this a bit more accurately. And you can't really. This one says 15J. So it kind of reads the same as a resistor. You have a couple of numbers potentially, although they're printed numerically here and not in colours. And then the last digit on this is then another number, which is missing from this one. I'll explain why in a second, which is the power of 10 that you multiply this by. So this one says 15J, so that is 15 picofarads. So by default they're in picofarads, and the J means plus or minus 5% tolerance. So this one is 15 picofarads. The next one along, really common one, this is a 102. So that's 10 times 10 to the power of 2, and I'll make that 1000 picofarads. So that should come out as 1 nanofarad when we test it. And finally this one says 473Z. So that's 47, 10 to the power of 3, which converts the picofarads into nanofarads. So that's 47 nanofarads. The tolerance on this one is a Z. Typically that means minus 20% or plus 80%. I think that's quite an unusual marking for a ceramic disc capacitor. That's normally marked on an electrolytic capacitor. Somewhat like one of these. They have polarity marked as well on an electrolytic, where it's the minimum capacitance is typically the most important. So they guarantee it minus 20% and plus 80. Okay, let's so before you test any of these capacitors, it's very important that you dop it against a bit of metal to make sure it's discharged, so the multimeter can do its thing. I wouldn't suggest doing that with some of those really meaty electrolytic capacitors, because you might end up taking your hands off. There are safer ways of discharging those things, but this is specifically ceramic capacitors today. So again, the marking's 15J, so plus or minus 5%, and it's 15 picofarads. So we'll move this down to the lowest possible setting, push the capacitor in, and you can see 0.017 nanofarads. And that is indeed 17 picofarads. And this is marked as 15, so it's not bad actually, it's moderately accurate. You have to take into account, of course, that is marked as a J, it's plus or minus 5%, and then also add to that there will be inaccuracies stated in the specifications of the multimeter itself. So the second one here is 102, so I'll make that 1 nanofarad. So the 2 nanofarad limit on the multimeter is still valid. Push that in, and you'll see it's sort of charging up. Quite often this value during the testing process can go up and up and up, and then it recedes again. It's a bit of a strange thing. Some multimeters, I mustn't touch it either, just see the effect of that. Some multimeters have the max function, so once it gets to the top it will hold it. I think that's pretty obvious from looking at that. We can see that's 1 nanofarad. It's 2% under, so it's well within any kind of tolerance you may have there. Take the max off, back to 1 picofarad. Okay, finally 473Z is the marking, and you've got 473, so that means 47 nanofarads. So you need the 200 maximum range for this. Press max again, stick this capacitor in, should be 47 nanofarads. Let's see how accurate it is. You can see it's charging it up. They're working out the capacitance. And you can see the rate of change slows as it reaches the actual capacitance. So 46.9 nanofarads when it's supposed to be 47 nanofarads. That's close enough for me. So that's a very short introduction. I'm actually quite surprised at how accurate this is, and how accurate the capacitors are made, but also, more importantly, how accurate I think this probably is. And it's been a bit of an eye-opener there. But there you go. That's the basics of capacitor markings. There's millions of things online. I just wanted to give you a simple practical demonstration on ceramic disc type capacitors, and also the measurement using a multimeter. This is a precision gold. It's a Maplin unit. Maplin are obviously not trading anymore. Somebody commented to me the other day that maybe they're still just trading online, but they don't have any shops anymore. I didn't buy this as the company was closing down. I bought it in a sale several Christmases ago, and been actually really quite happy with it. And as you can see, quite accurate. Brilliant stuff. Hope that helps somebody, and always feel free to drop me a line. So this is Rob, G7LAS, is saying 73. Cheers.